Now here's my job. My job is to prove these theorems. I never did prove them for you. So I'm going to prove the fundamental theorem of calculus, but I'm going to do 2 first, and then I'm going to do 1. And it's just going to take me just one blackboard. It's not that hard. The proof is by picture and using the interpretation as area under the curve. So if here's the value of a, and this is the graph of the function y equals f of x, then I want to draw 3 vertical lines. One of them is going to be at x, and one of them is going to be at x plus delta x. So here I have the interval from 0 to x, and next I have the interval from x to x, delta x more than that. And now the pieces that I've got are the area of this part. So this has area which has a name. It's called g of x. By definition, g of x, which is sitting right over here in the fundamental theorem, is the integral from a to x of this function. So it's the area under the curve. So that area is g of x. Now this other chunk here, I claim that this is delta g. This is the change in g. It's the value of g of x that is the area of the whole business all the way up to x plus delta x minus the first part, g of x. So it's what's left over. It's the incremental amount of area there. And now I just am going to carry out a pretty standard estimation here. This is practically a rectangle, and it's got a base of delta x, and so we need to figure out what its height is. This is delta g, and it's approximately its base times its height. But what is the height? Well, the height is maybe either this segment or something in between, but they're all about the same. So I'm just going to put in the value at the first point. That's the left end there. So that's this height here is f of x. So this is f of x, and so really I approximated by that rectangle there. And now if I divide and take the limit as delta x goes to 0 of delta g over delta x, it's going to equal f of x. And this is where I'm using the fact that f is continuous, because I need the values nearby to be similar to the value in the limit. Okay, that's the end. This is the end of the proof. So I'll put a nice little QED here.